All right, so today we're going to work on solving exponential equations with the same base. We'll then go into solving exponential equations with unlike bases. We'll then solve exponential equations when b is less than 1, greater than 0. And then we'll work on solving by graphing. Okay, so today's main focus is solving exponential equations. All right, so we have an exponential equation here where we have two bases that are alike. So how we'll know if the bases are alike is this one has a base of 3, this one also has a base of 3. So because their base is greater than 0 and it's not equal to 1, okay, then their exponents are equal to each other. So what that means is that x plus 1 is going to equal 5. So in order to figure out what x will be, it's like solving an equation. So x plus 1 equals 5. Subtract 1 on both sides, x equals 4. Okay, so the value of x here, in order to make this equation true, would have to be 4. All right, so we're solving an exponential equation with the same base again. I know it's the same because this has a base of 6. This also has a base of 6 here. So in order to solve this equation, I'm just going to go ahead and set their exponents equal to each other because their bases are the same. If we look at our first one, our exponent here is just going to be 1. Alrighty, and that's going to equal 2x minus 3. If you add 3 to both sides, you're going to go ahead and get 4 is equal to 2x. Divide both sides by 2. X equals 2. If we look at the next problem to our right here, again, same base. This has a base of 10. This also has a base of 10, so I can go ahead and set their exponents equal to each other. So 3x is equal to 2x plus 3. If I subtract 2x on both sides, x equals 3. All right, I'm going to go ahead and have you guys try these 3 problems on your own. Please make sure you are recording your own work on the paper I have provided you. All right, so you guys can go ahead and stop the video, solve it. I'm just going to go ahead and provide you with the answers to these 3 questions. Keep in mind you need to make sure you're showing your work on your paper. Alrighty, but I will provide you with the answers so you can check your work. So for the first one, you're going to get x is equal to 3. The second one, you'll get x is equal to 1. And the third one, you'll get x is equal to negative 2. All right, now we're going to move into solving exponential equations with unlike bases. All right, in order to solve an exponential equation with an unlike base, you need to first rewrite each side of your equation so that they have the same base. All right, so my first example for you is going to be 5 to the x power is equal to 125. You're going to notice here that the base of our expression on the left is 5, where the base here is 125. Okay, in order to figure out what x is, we have to make sure we're rewriting this base with a base of 5. So you have to think to yourself, okay, if my base is 5 to the what power will produce 125? Okay, and your answer here will be 3. So now I've rewritten 125 with a base of 5, all right, and now I can go ahead and just bring down the rest of my expression, all right, and then I can solve it the way I would solve with like bases. So again, we have like bases here, we have 5 and 5, all right, so we can just go ahead and set their exponents equal to each other, so x is equal to 3. All right, so we have another example here. We're solving equations with unlike bases again. You're going to notice here when looking at my equation, I have a base of 4 and I have a base of 2. All right, so looking at this, we're going to want to go ahead and rewrite my base of 4 with a base of 2 here. So 2 to the what is going to give me 4? 2 to the second power, all to the x power. Okay, and I can go ahead and just bring down the other part here, so 2 to the x minus 3. And now that we have like bases, we have a like base of 2 here and a like base of 2 here, we can go ahead and set our exponents equal to each other. So that's going to look like 2x is equal to x minus 3. If you subtract x on both sides, x is equal to negative 3. Alright, so this is our last example of solving with unlike bases. You're going to notice here that I have a base of 9 and I also have a base of 27. Okay, no matter what I do here, okay, I can't change 27 to be a base of 9. So what I'm going to have to do is change both of these bases so that they have a common base. Alright, so our common base here is going to be 3. Okay, 3 to the second power all to the x plus 2, all right, is what I'll get for my first expression. And then 27, well, 3 to the what power will give me 27? That's going to be to the third all times x. And now that we have our bases that are alike, we have a base here 3 and a base here 3, we can just go ahead and set their exponents equal to each other, except there's one little thing I want to show you. All right, you're going to notice here that this is 2 times this entire quantity. Okay, so this is going to become 2x plus 4. Okay, and that one will just stay as 3x. All right, so when I set them equal to each other, I'm really going to have 2x plus 4 equals 3x. And when I subtract 2x from both sides, 4 is equal to x. Alright, so we have more solving with exponential equations and unlike bases. So before, the problems that we saw were when we had whole number values for b. Okay, and now we're going to talk about values of b that are going to be less than 1 but greater than 0. Alright, so if you're looking at our first example here, our b value is 1/2. Alright, so our goal is to rewrite our b value so that it's a nice whole number so that we can get a common base. Alright, so the way we have to kind of ask ourselves is, how could we turn 1/2 into a whole number? Okay, and the way you can do that is thinking to yourself, well, 1/2 is the same thing as a base of 2 to the negative first power. Okay, because 2 to the negative first is essentially 1/2. So we're going to rewrite 1/2 as 2 to the negative first all to the x power. Okay, and we're going to set that equal to a new base for 4, because we want to make sure that our bases are the same so we can find x. So you have to ask yourself, well, here I have a base of 2, so I also want a base of 2 for 4. So we're going to go ahead and make it 2 to the second power, because 2 squared gives us 4. Now we can go ahead and set our exponents equal to each other. So negative x is equal to 2. Divide both sides by negative 1. X equals negative 2. All right, we're still solving here. Okay, you're going to notice here that, yes, on our first base we have a 4, but our second base here is 1 over 64. So we want to go ahead and turn 1 over 64 into a nice whole number base so that we can compare. So we first have to ask ourselves, well, if this first base is 4, is there anything with a base of 4 that will give us 64? Okay, and that answer is yes, there is. Okay, 4 to the third power will give us 64. So I'm going to write that as 1 over 4 to the third power, because that's the same thing as 1 over 64. All right, but again, it's still less than 1. We want to make it greater than 1. So we're going to take our 1 over 4 to the third power and make it 4 to the negative third, because that is the same thing. 4 to the negative third power is the same as 1 over 4 to the positive third power. Okay, so now we have our new equation. 4 to the x plus 1 is equal to 4 to the negative third. We can go ahead and set our exponents equal to each other. X plus 1 is equal to negative 3. Subtract 1 on both sides. X equals negative 4. All right, so I want you guys to go ahead and practice solving the exponential equations here. All right, you can stop the video, solve these 3, showing all your work on the paper that I've provided you, and then you can go ahead and click play in just a moment, and I will give you guys the answers. All right, so the first answer is going to be x is equal to 4. Second answer here is going to be x is equal to -2. And then for our final one, x equals -2. All right, so we've been solving equations with like bases, unlike bases, when your p-value is less than 1 but greater than 0, okay? And they've been working out really nicely, but sometimes it's impossible to rewrite each side of an exponential equation using the same base. Okay, so if we're looking at my example right in front of us, we're going to see that our first part of our equation has a base of 1/2, and the second part of our equation has a base of 7. Okay, so it's impossible to find a like base that will give us the true value of x. So what we're going to need to do is solve these types of equations by graphing each side and finding their point of intersection. All right, exponential equations can have no solutions, one solution, or more than one solution, depending on the number of points of intersections. So it's important that when we're graphing, we're making sure that we're finding every possible solution. All right, so your first step here is you're going to want to, write a system of equations using each side of the equation. So what do I mean by that? I mean typing in each side of my equation as its own equation. So 1/2 to the x minus 1 will be one equation, and 7 will be one equation. And that will just simply look like y is equal to 1/2 times x minus 1. And my second equation will look like y is equal to 7. Once I have these equations written out, I can go ahead and enter the equations into my calculator. All right, you can enter in your first equation for y1 and your second equation for y2. Once your equations are entered in, all right, and your y equals, you can go ahead and just hit graph. And if you're in a standard 10 by 10 viewing window, you're going to start to see your exponential function formulating along with your linear function. All right, so I've kind of drawn a rough sketch right here of what your graph should look like. All right, my red line is my exponential function, my blue line is my linear function, and you're going to notice that they are intersecting right here at this point. So our goal is to figure out what is that point so we can figure out what the value of x will be. In order to do that, you're going to go ahead and hit second trace. Okay, go to option 5 where it says intersect. Okay, it's going to ask you for the first curve, the second curve. Okay, you're just going to hit enter, enter, and enter. Okay, and then it'll populate and give you a value below that says x equals -1.80735 and y equals 7. So we know that y is going to equal 7 when x is approximately -1.81. All right, so once we've graphed it and we found our point of intersection, this is where LT6 kicks in. So LT6 is your guys' ability to solve equations and inequalities using graphs, tables, and technology. So what you should remember is from last unit when we were solving equations with our cubics and our absolute values and finding when the values of y were larger on certain functions than they were on others. Okay, so we're just going to kind of break apart this graph and analyze, what's happening here. So if I look at this graph, I want you to notice that my blue line here is going to be my linear function, okay? And this is the graph from our previous question, all right, where y was equal to 7. All right, and my red line is going to be my exponential function, which is going to be y is equal to 1/2 to the x minus 1. So now that I know which line represents which, I'm going to ask you guys a few questions and we're going to kind of go over this. So my first question is going to be, when will my y values on my exponential function, be less than my y values of my linear function? Okay, so what will x be during that time when my y values of my exponential function are less than my y values of my linear function? And to determine that, I can go ahead and analyze my graph. So when are my y values of my exponential function less than my y values of my linear? And so if I look at that, I'm going to notice that all of these y values right here are less than the y values of my linear function. So I can say that, when my y values of my exponential function are less than the y values of my linear function, x is greater than negative 1.81. Because we've just said here that they're all of these y's. Okay? And x at that time is everything that is greater than negative 1.81. Okay? And that would answer that question. When are my y values of my exponential function less than the y values of my linear function? All right, so now that we've done the other one, now my next question is, well, when are my y values of my exponential function greater than my y values of my linear function? So if I look at my graph, you're going to see that all of these y values of my exponential function are greater than the y values of my linear function. So x at that time will be less than negative 1.81. All right, so now we've covered pretty much LT6, okay? LT6 is pretty much those last 3 slides of being able to enter your data into your calculator, okay? Find that point of intersection and then analyze the question, okay, to see where our solution falls, okay? Tomorrow in class, we'll talk more about real-world problems. I just want to make sure that you guys come to class knowing how to graph these certain equations, okay, so that we are ready to go. So go ahead, rewatch this video a few more times, make sure you got everything down, and then if you have any other questions, please make sure to ask tomorrow in class. All right, I've given you 3 different equations to solve here. All right, I'm going to go ahead and leave you guys with the answers, but I want to make sure that you're practicing and drawing a nice sketch on the worksheet I gave you guys to kind of record your answers.